Hello, this is Sumantho Day and welcome to SD Lessons. Today my subject is mathematics and the topic is trigonometry. So let's start. Now, what is trigonometry? Tri means three, gone, sides, metry means measurement. That means some measurement that is involved with a three-sided figure. However, we will be considering, means it is connected with a right angle triangle only. But before I go into the actual part, let's consider this one. Here, look at this one. Here is a river. There's a tree at the other side of the river. Someone is standing here, just opposite to the other side of the river, other bank. And he wishes to calculate the width of the river. Without crossing the river, he wants to know the width of the river. So what he does, first he positions himself just at the opposite side of the tree, and then he marks that place, and then he walks away slowly, and he comes to a point where he finds that he is 45 degrees with the tree and the bank. Okay, now if he has walked 650 meters away from his initial position, what is the width of the river? This is actually to do with this, but we can say that if this is 650 meters, this will be also 650 meters. Using the concept of trigonometry. Let's see the next one. Here is Qutub Minar. A boy is standing just at the base of Qutub Minar and he wants to measure the height of Qutub Minar. He doesn't know. What he does, he walks away from Qutub Minar. He lies down on the ground to make it more accurate, and then he looks up to the tip of Qutub Minar. If this angle is 45 degrees, he goes far away and lies down where he finds it is 45 degrees. If it is 43 meters away, Qutub Minar is also 73 meters away, Qutub Minar is also 73 meters in height. But both the examples I have given with 45 degrees. That means this was 45, this was also 45. Can we do with other degrees? Definitely. For that, we have to delve in deeper into the various relations. Let's see one by one. Now, trigonometrical ratios. Before we know the ratios, let's see one right-angled triangle. Got it? Opposite to the 90 degree, we call that side as hypotenuse. Here it is written as H. And there are two other sides. This is one that includes the 90 degree. One of the sides is called perpendicular, one of the side is called base. That is regarding that in connection to the acute angles. What are acute angles? There are two acute angles. One is this one is this one, less than 90 degree. If you take this acute angle or this as the reference angle, if you take this as the acute angle or reference angle, then opposite to this angle we call P or perpendicular, and the other one we call it base. But if you switch over this reference angle to this one, then this P will be this one and B will be the other one. Keep that in mind when later on you have to solve the sums. Now, there are three sides, H, P and B. How many ratios are possible with these three sides? 6 ratios. I have written 6 ratios. P by H, H by P. Reciprocal of that. B by H, H by B. Another reciprocal. P by B, B by P. Another reciprocal. But it becomes difficult to remember in that way. That's why some names are given. What are these names? Sine, cosine, tangent, cosecant, secant and cotangent. And what is this? Theta. It's a Greek letter. We use this as a convention. You can also use English letters like A, capital A, B and so on. But conventionally we take theta, Greek alphabet theta. Let's see. Sine theta, which ratio? P by H, this length divided by this length. P by H. Cosine B by H. Tangent P by B. Cosecant H by P. Secant H by B. Cotangent B by P. But you don't remember in that way. You will forget. There are some techniques. Various authors have come up with various techniques in Hindi, in Bengali, in English. I will tell you one. How do you remember? Some people have some S. Sine is perpendicular by hypotenuse. Some people have curly brown hair. Cos theta is B by H. Turn permanently black. Again, some people have curly brown hair. Turn permanently black. And how do you remember these three? Just the reciprocal of this. Cosec is reciprocal of sine. So people have. Sec is reciprocal of cos. So brown hair. From down you go. Brown hair. And cotangent or cot is reciprocal of tan. Permanently black. So once more I go. Some people have curly brown hair, turn permanently black. And cosec is reciprocal of sine. Sec is reciprocal of cosine. Cot is reciprocal of tan. I will now discuss with some formula which we call identities. 3 main identities. 1, 2, 3. And to understand this, you need to understand any right angle triangle. I have taken a simple one. Do you remember Pythagoras? If you don't, you listen to me well. Pythagoras Theorem. What is said in that? Just a hint I will give you. A right angle triangle. I have taken 3, I have taken 4, and the hypotenuse I have taken 5. The longest side is the hypotenuse, 5. Let's square it. Square of 5 is 25. Square of 3 is 9. And square of 4 is 16. What's the connection? What Pythagoras, how did he connect? 9 plus 16, 25. See, it goes with this. So square of this plus square of this gives square of the longest length. How do you write that? H square or hypotenuse square is equal to P square or perpendicular square plus B square, that is base square. Remember that. And with the help of these numbers or this triangle, we can take any right angle triangle with any measurement. Any measurement. But I have taken this one to prove these three identities, just to check whether it is really so or not. Let's see the first identity. Sine square theta plus cos square theta equals 1. It is said. Let's check. Is it true? Sine square theta means the value of sine theta. Now let's see what is sine theta. Sine theta. Some people have 3 by 5. 3 by 5 written. Square it is written means it has to be squared. Cos square theta. Curly brown hair. That means 4 by 5. 4 by 5 written. Cos square, so it is squared. Will it come to 1? Definitely. Let's see. 3 by 5, if you square it, it will come to 9 by 25. Okay? And 4 by 5, it will come to 16 by 25. 9 plus 16, it will come to 25. 25 by 25, you calculate, you take a rough copy out, you calculate, you will find it will come to 25 by 25, that is 1. That verifies the first identity. Let's see the next one. 1 plus tan square theta equals sec square theta. 1 tan, ectan. You remember in very many ways, funny ways you try to create yourself. Ectan, actane shekha. In Bengali you can think, in Hindi you can also make it, in English also you can make it. So 1 plus tan square theta equals sec square theta. You can remember I said actane shekha. So let's see 1, tan, turn permanently black. Turn permanently black. 3 by turn permanently black. 3 by 4. Again once more, turn permanently black. 3 by 4. Square it. If you square this, 9 by 16, 1 plus 9 by 16, that will give you 25 by 16, that is sec square theta. Sec is h by b, 5 by 4, this is 5 by 4. You square it, you check out yourself, left hand side will be equal to right hand side. Okay? And the third one, 1 plus cot square theta equals cosec square theta. Ac, cot, cosec. Now you remember in different way. 1 plus cot square theta plus cosec square theta. Now cot is 4 by 3. What is cot? B by P. B by P. 4 by 3. And what is cosec? 5 by 3. Cosec is h by P. So 5 by 3. If you solve this, you will get that the left hand side and the right hand side will be equal. So to solve or to apply, you will get trigonometrical identities sum. Based on these three, you have to solve them. That I will deal, of course, later on in my continuation class. You will also get sums like heights and distances. Height of a tree, height of a mountain, how far is it? But the basic concept is you have to know this, and you have to know these three identities and to apply them. There is nothing beyond that. You can also find out if you move a certain distance. Suppose if you move for 1000 kilometers from Kolkata to Delhi, and if you look at a planet, and if there is a change, slight change in its degree, is it possible to get the distance of the planet? If you are very accurate, it is possible. It is possible. And that is how Without going to the space, we can still calculate the distance of a planet. Actually, this branch of mathematics is very interesting. Without climbing the Mount Everest, we can tell its height. We may not be very accurate, but still we can calculate more. In my next lesson, I will solve some sums. I'll show you. Till then, goodbye, and definitely, as usual, which I say, share, subscribe, comment, and like. Thank you.